Hi everybody, Nem here, and this is just what it looks like. My brand new CR10 Smart, still in the sealed box, and tonight I am going to unpack it and build it and print something on it and take you along for the ride. First things first, we need to unbox it. Got my handy dandy MacGyver knife. Slice, slice, slice. Try not to slice my fingers like my wife did. Whoa, we got destructions here. Always nice to have cautions. The first thing you see when you open a box. I guess that means I'll need to go check my profile. Hey, looky, we've got a destruction manual. Oh, and the tiniest little spool of printer filament I have seen in my life and bothered to actually put it on a spool. The spool is probably worth more than the filament. Let's see here. Awesome. Oh. Ooh. Yeah, okay. Let's fuck over. Down to the nitty and the gritty. Parts. Parts, 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 parts. Well, this is not the parts I want. First tray is all this stuff, which I am not going to need for a while. So I'm going to set this aside. Second tray is the gantry. Very nice. Look at that level of completion. Very nice, very nice. Oh, and look at that. Dual Z's. And they are tied together with a belt just like my CR6 SE. Tasty, tasty. And they have the Creality solid. Well, semi-solid. Just a single slot in the Z-axis couplers. No, they are, however, not slop-free Z-axis nuts. But hey, I'm just the weirdo who bothers with that kind of stuff. Again, setting it aside for now until I have the base out. Oh, lots of foam flying everywhere. Now, I'm going to be honest, I did cheat a little bit, and I downloaded the owner's manual on this. Well, geez, when I ordered it. And I've read it, and the assembly is almost identical to my CR6 SE, only it also has separate triangulation struts that have to also be installed. Aside from that, it's pretty much identical to the thing. Ooh, the peel. Nope. We'll save that for after it's all built. Because I'm a klutz. Ooh, look at that. Clever. They've even got everything taped away so that you can't hurt it until it's all assembled. Sweet. Alrighty. Oh, okay, guys. Where did you put the toolbox? Does this? Oh, wow. Ew. Wow, that one is in there tight. Oh, look at that. Oh, how cute. Yeah, not going to stay that way. I do not have the patience for that crap. There we go. Hey, that fits pretty snugly in there. That is not going to fall out. All right. Doodly 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 doo. All right. Well, that's the bottom of the box. Have to admit, I'm not best pleased by this. This is one of the reasons why I didn't buy these from the aftermarket, is because they all come with this split joint in the middle. I'm definitely going to have to abuse that with some pliers to get it tight to my taste. Interesting, they did include spare parts for the extruder, and looks like a spare Bowden too. Now, where in here is there? It is. Need midget orangutan contortionist fingers to get stuff out of these slots. There's all the parts. Hey, remember me? Reminds me of those eraser programs in Tron. They're coming for you. All right, do I actually have enough room, even on my cleared off bench, to turn this on its side and put it together? That's a good question. We're gonna find out. Get my scroomy doomy doomies for the gantry together before I start messing around with any of it. Oh, look at that. They even come with pre-installed lock nuts. How Batman is that? See if I can get a little bit more room for that gantry to lie down. Slide all of you back. Oh, what the heck. Let's be brave and just use the toolkit that came with it. They suck, but they are adequate to do the actual assembly. I proved that to myself with the CR6. The first one is always the worst pain in the patookie. Yes, and I know somebody is sitting there looking at oh my God, look at that crap in that slot. Yes, I looked at it very carefully. It is not where it can protrude below and interfere. It is started, so I should be able to turn this sideways now. With that edge hanging off, the edge of the bench a little, so I can get in there with my zippy ties. I mean, not my zippy ties, my Allen wrench. Oh, you popped loose, you little horrible. See, you get to see me fighting it. Just like anybody else would have to do. There it goes, it popped out of the slot, that's why. I thought I had it started. That's what you get for thinking, old man. There he goes, snugging up smooth like butter. Gravity, you're a bitch. Alrighty. And now we are at such a point that I can show final tightening of the Allen wrenches, Allen screws in the gantry. And there we have it. The hard part is actually already done. Guess maybe they expect us to tape those down that way, but I'm feeling brave. Wow, that is a first experience for me. That x-axis, or that z-axis, is loose as a goose. That is not what I had with the CR6. Alrighty. Well, that is going to add some time to it. First, I'm going to do the basic assembly yet. Oh, I see. All right. It's not horrible. It's actually pretty simple and straightforward to resolve. All right. is actually all of the assembly aside from the threaded rods and the faceplate. It's already starting to look like a 3DP. Oh my Jesus God, you're kidding me. Faceplate just pops on, huh? How clever. Not sure if I like that. I really kind of like the fact of having a screw to hold it down on the older models. Well, that was fortunate. This is another one of those cases where you want little teeny tiny Asian girl fingers for getting in there to put things together. Yeah, you know what? I think I'm going to leave that off until after I have the Z-axis resolved. Or the Y-axis, rather, resolved. Ooby-dooby-doo. Ooh, look at that shiny metal knot button. All the more to electrocute you with. Dooby-dooby-doo. Shmooby-dooby-doo. I know I got some thread locker here somewhere. Hi. Oh. Okay. The red, whatever. I'm going to go stick these in a vise and tighten them up a little bit. I'll be right back. Ow! Fucker. Land at your bitch. My friend, there we go. Don't. Hey, at least make the show entertaining. All right. Are they tight? Oh, they're as tight as I could get them. In a vise with cardboard clamped around it. So, we'll find out. Here's our other screwy doomy doomies. quite frankly, is not the best design in the world. They should have, right in here where I'm working. Stop fighting. Right in here where I'm working, they should have counterboard and actually used a machine spacer instead of this washer and just drilling into the slotted channel. That does not strike me as best practice for sure. But I'm sure that just to triangulate the chassis, it's going to be tolerable. Just not best practice. Get that, yeah, about centered between the two.
Your mama. Oh, where'd you go, you little gabble? Ah, there you are. Thank God my magnet's smarter than I am.
Seriously, guy? Seriously? Not my imagination. Okay. That's a new one. Probably gonna need SAE. I don't know if I have one handy. Fuck a diddly do. Yeah, one of the screws has the wrong size head on it. 'Cause that's what you get when you buy bulk from China. The other three are exactly where they should be. One of them looks like it's a 1/8. All right, upstairs again to the big toolbox.
Hey, Daddy. You look for just a second?
Ah, alrighty. That is one pimped out controller. Oh, there once was a young man from Boston who drove around in an Austin. But the car was so small, he had to hang out his balls. And he drove past a phone pole and lost them. Ay, ba-doop-a-doop-a-doop. Let's see here if this works a little better. Wow. Really? There we go. Ah. Now, back to our regularly scheduled insanity. Tighten these screw-me-doomies down.
Let's see here. Use the included winchy winch to tighten the lock nuts.
Yes, I guess we should turn it so you can actually see what the heck I'm doing instead of just listening to me grunt and groan. I know I don't make things very interesting. I'm sorry. I'm mostly about getting the job done. I would never make a great YouTuber. I don't know how to hype shit. Ugh. Alrighty. So now it's just a matter of snugging up those Y-axis bolts, but it's pretty easy. I mean, this is not something that the average novice would know. They probably would have to ask for some help in one of the chats. The rollers on this are adjusted with a cam nut that adjusts the tension against the V channel. Look at how nice and wide that is, though. Ooh, I love that stable base. Now, if it was just tight, then it might actually be stable. Anyways, let me just check these to make sure. They're tight, but they're not Gorilla Dragon tight. Anyways, and of course there's two of them that are a different size. That was not best engineered, guys. No. Anyways, they're leastwise on the CR6, they are tightened with a lock nut, so that there is a fair amount of preload against them, and you literally just turn them to get the tension right against the V channel. And let's see here.
Looks like all the ones on the left are about right. And all the ones on the right are pretty loose. So, just give it a little turn there. Turn there. Getting better. There. Oh, come here. Get on the nut.
I'm gonna have to turn this on the side so I can actually get some light in there. See what the heck is going on. does not seem to be responding the way I expect it to. And it's going from almost starting to tighten up to that. There we go. Just needed a little bit longer. A little bit more turn. All right. So, back it off a little. Yes. Plug it up. Yes. Back it off a little. Plug it up. What the actual fuck? That is fucked. Oh, okay, no, it's not that, it's me. That's fucked. Oh, god damn it, that still seems wrong. Because it's snug at the end, but not, but loose as a goose in the middle. All right, well, there you saw it. My fabulous new printer is fucked up from the factory. I am literally going to have to do something to try and straighten out these two rails and get them parallel, because they're squeezed together in the middle. Just for grins and giggles, let's see if I can measure it. Oh joy, it's doing that stupid battery thing again. Old dragons never die. They just smell that way. And this is my slightly better Chinesium calipers. No, I can't complain. Those poor Pittsburgh forges have been with me for decades and they have been abused. Okay, 129.43 millimeters there. One 28.77 millimeters there. and 129.6 millimeters there. So they bow in the middle, inward, almost, good Lord, 0.8 millimeters? That's ridiculous. Build it straight and square, straight and square, straight and square. That is the fundamental laws of a 3D printer. If you don't start out straight and square, you're fucked. Hasta lasagna, guys. I'll be back when I have more news.
5 minutes later.
Okay, guys. I have found that by using the very scientific method of applying a little tweak here while I loosen and tighten the bolts. Very scientific, yes, I know. I was able to get the runout down to about 20, about 10. About 0.10 millimeters, which I know is not really high precision, but then again, these are not a high precision device. That's why they're made with rubber tires. But the short version is I can at least get the rollers to snug up like they're supposed to throughout the entire transit. Yes, I know everything that is wrong with doing it that way, and I don't give a fuck. I know that these are not the most precise printers in the world. They are, however, simple and rugged, and that's why I like them. So now I'm going to finish my adjusting of the rollers, and we're going to try and print something with this. Now this is the kind of thing that I would not expect the average idiot first-timer to know how to do. I will admit that. Or even the average, smarter than the average bear first-timer. In all honesty, I wouldn't have expected me to know to do this when I first started. So... Alrighty. Yeah, that's definitely a bit more of a hairball than I was expecting to get into. So, strike one up against Creality for their implementation on this. The bottom line is this whole setup here is different on the CR6. It's actually one big piece of extrusion that's about this wide. And obviously you can't, assemble that so that it's not straight and square. So this, while it looks awesome, there's plastic squares on the end and it just bolts in place, which means it's entirely subject to how carefully the thing was assembled as to whether it runs straight and true. So that's the kind of thing that should be assembled with a jig so that it can't not be square. And it's obvious they don't do that with this design. So that's one thing that is not the same between this and my CR6 SE. Alrighty. So now, alright. Pretty much should be a matter of just assembling the panel on it. I'm going to be brave, and I am going to power it up with you. Looking right over my shoulder. Well, looking right over its shoulder. Wow, could I do that any more stupidly? I mean, like, literally. Get your yucks in, guys. I know I'm ridiculous. That's why y'all tuned in. All right, now we're going to do that piece. This is the Seriality, or Creality, or whatever you want to call it. Well, it's a carborundum printed surface. It does seem to wear pretty well. And as you can see, the glass is held in place by those cam locks, which is a nice setup. This stuff bonds very well when it's hot. And when it cools off, stuff does just pop off as promised. And let's see here. We'll slide this back absolutely as far as we can so you can see the screen. And main power on and contact. Wow, it's not really impressed, is it? Oh, there we go. Press and hold, dummy. I don't know if you can see that that Creality logo. Awesome.
Many hours later.
Hi everybody, Nem here. That video goes on to pretty much complete assembly of the printer, and I do successfully print a couple of perfectly usable objects with it. So from that perspective, the CR10 Smart is a success. But I want to stop here and talk about the frame geometry on these things and the essential design because it's important, and I feel that it is an area where the CR10 Smart is lacking. So I'm going to get right into it. Most of the smaller entry-level V-slot printers, like the Ender and its clones, we use H-frame design, which is milled end 2040 or 4040 extrusion, and it's bolted through the extrusion into the ends of the corresponding pieces, and by its nature that pulls everything together so that it makes a straight and square and pretty rigid design. This, my Digro, it has, it's elevated so that all of the stuff is open work. Some of the newer ones are covering that stuff up with metal, but it's pretty simple. As long as the pieces are milled straight and square, when you go to assemble it, it pulls itself into a frame that is straight and square. And it's a good foundation for a starter level, entry level machine like this one. Now my CR6 SE builds on that. Actually, the full frame, the entirety of the H frame is 40/40 aluminum. 4 bolts, 20/40 aluminum, and bolted this way as well. But where it's really over the top is the Y-axis. This is all one solid piece of extrusion, which is essentially a 20/60 extrusion and a 40/40 or a 40/20 extrusion molded into one piece. And that bolts directly to the center of the H, just like the older Ender series. Let's see if I can show that here. Here we go. And again, by its nature, the way it's machined and the way it's assembled, it makes a rigid square frame that makes itself square when you assemble it, as long as you're not completely careless while you're assembling it. Also, the 60/20 V channel here broadens the base, so it gives it more lateral stability. And it's a really stout piece of extrusion, so it's really rigid in all directions. Which, I mean, that's just awesome for this size of a printer. It is really rigid and really rugged and really robust. Now, the other common design is the original CR10, which this, my Tornado, is a cousin or a clone, whatever you want to call it. And it's a box frame design. As you can see, 20/40 here, 20/40 here, and 20/20 here and here. And then the Y-axis rail bolts across the cross members. And that too is a pretty rigid, pretty stable design. Not as stable laterally because it's only 20/40. Okay, but it's still functional. And again, just like the other ones, these bolt in from the end so that they pull themselves straight and square, but they reinforce with plates here and here and here because it's a bigger format printer and it has a lot more leverage. So as you can see, yeah, it has some give, it has some flex, and ringing artifacts are a problem with all of this family of printer unless you triangulate the chassis from here to here, which makes a huge difference. Now, the CR10 Smart incorporates that and the usual 40/40 on the side rails of the main frame and 20/40 here. And again, as you can see, milled ends, end bolts through it so that this part here pulls itself together straight and square, just like it ought to. But where it deviates is in the Y-axis. The Y-axis on this is just 2 pieces of 20/20. Side by side. The alignment of those is essentially provided by this piece of molded plastic and this piece of molded plastic when it's assembled. And the core design of the frame is not the box design that all its predecessors, well, that I know of, enjoyed. But no, it is, as you can see, we have one piece of 2020 up here supporting the back of the y-axis. We have a piece of 20 by 40 here in the center of the y-axis. And actually the way it's cut out, it's actually effectively just a 20 by 20, which is not really exciting to be at all. And up in the front, there's nothing. All this is plastic and tin up at the front. And furthermore, unlike all the previous designs where all of the core pieces bolted directly to extrusion against extrusion, solid and square, this is sandwiched under the plate and there's a spacer underneath. So multiple layers that are not going to be perfectly flat and square. And unlike the CR6 where this tin is all cut out around everything and it's all still extrusion against extrusion, so it's square and straight, this 1 millimeter or so plate on the top and the bottom is enough to throw it all out of whack. I mean, between all of it, it simply is not the rigid, square, stout design that even the original CR10 had. So I'm greatly disappointed in this. I cannot recommend this printer to anybody because of that fundamental flaw in the design. I mean, yes, I can sort this. I can get this straightened out and tweaked so that if I put it on a flat surface, it's going to sit flat and it's going to work. Yes, I can do that. But these machines, these are supposed to be for entry level. These are supposed to be for non-nerds who just want to print stuff. And I see this unit as a huge step back from the CR6 SE, even though it shares a lot of the same hardware. The fundamental chassis design is weak, and I just can't recommend it. Thank you all, and tune in next time. Nem out.